Simplify g of x equals the square root of f of x divided by f of x, and hence calculate the derivative g dashed of x. So starting with our function g of x, this can be written as f of x on the top line to the power of a half divided by f of x on the bottom line to the power of 1. And now we know from our index laws that when we have the same base, in this case an entire function, we can simply subtract the powers when we do division. So this will turn into f of x to the power of negative 1/2. And now we have a function inside another function, so we know that we can apply the chain rule to differentiate this. And from the formula sheet, we know that dy dx, the derivative, is equal to dy du times du dx. So to help complete this question, we're going to let u be the inner function. This time it's represented symbolically as f of x. F of x is the inner function. And therefore the function y can be written as u to the power of negative 1 divided by 2. So as a part of the chain rule, we need to calculate dy du and du dx. So starting with du dx, this is going to be symbolically just f dashed of x. So because we don't know the rule, we can't actually find a true expression for it, but symbolically the derivative of f is f dashed of x. And for dy du, we simply take the power at the front, which will be negative 1/2, times u, and when we subtract 1 from this power, we get minus 3/2. So now we can apply our chain rule, so I'm just going to write it out for us. So dy dx is equal to dy du times du dx. So g dashed of x, the derivative we are asked to calculate in this question, is going to equal, and first of all, dy du is simply equal to negative 1/2 u to the power of negative 3/2. So we can have negative 1 divided by 2 times u, but u is simply f of x, and that's going to be to the power of negative 3/2. And then we multiply that by du dx, which is simply f dashed of x. So that's multiplying by f dashed of x in the second set of brackets. So therefore, g dashed of x is going to be able to be written as negative 1/2 times f dashed of x times by f of x raised to the power of negative 3/2. So even though it's a little bit unusual, that is the answer to this question.